Welcome to another Holistic 3D YouTube tutorial. In this tutorial, I'm going to carry on in the same vein as the previous ones, which was on procedural terrain. Now, what I've recently done is to update my procedural terrain generation course, and in that you get to create these types of terrains which you don't paint in the traditional method by using a paintbrush and height values and that. You actually build this custom terrain script which has an editor where you can do all of these fantastic settings and put trees and textures and water and even clouds onto the landscape. Now, something we don't cover in that particular course is how to set these height values if you have multiple terrains. So this is a single terrain. If I click on this terrain object in the hierarchy and forget about my little script for a moment and come up here where we can add neighboring terrains, I can just click in these neighboring cells that you can see here and I will get new terrains. Now, the heights of those aren't automatically set, except you can see that they kind of grab onto the neighbor. But some of the algorithms in the course don't go over multiple terrains. If you want to know how you can get an algorithm such as Pearl and Noise over a whole terrain, make sure you watch the beginning of this particular playlist, which actually covers that. Now, items such as, or I should say algorithms, such as Pearl and Noise, and even multiple Pearl and Noise are continuous, which means that they basically travel along the X and the Z axes forever in both directions. So they'll just give you a continuous amount of height values. Unfortunately, other algorithm type methods for terrain generation, such as Voronoi, that you can see here, that we looking at in my course, and midpoint displacement, that you can see here, these types of techniques aren't continuous. So when you create them, you kind of create them for one basic array of height values, which you then have to translate onto your terrain. Now, as I said, these aren't continuous, so they're not just going to naturally flow over onto the next terrain. So in this lecture, I want to show you how you can actually use things like Voronoi and midpoint displacement on multiple terrains. And before we get started, just the obligatory reminder to subscribe to my channel and also check out my learning website, h3dlearn.com. In addition, if you'd like the source project for this particular tutorial, it's available to Patreon members, so make sure that you head over there and check that out. Okay, let's get started. Now, to follow along, you don't need any particular assets whatsoever. I'll actually show you how to create everything. I'm doing this in Unity 2023.2.16, so it's quite a modern version of Unity. That's if you're watching this video when I've created it, so just to check the date. But this has all been updated from the previous terrain system that I had in my old version of my course, which I've just updated. Okay, so we've got a scene open. It's blank, it's got a camera, it's got a light in it, nothing particularly special about it. What I'm going to do in the hierarchy is right click 3D object and add in a terrain. So you can find it just down there. Now, just as a little note, this will also work in the universal render pipeline and the high definition render pipeline if you want to use this code in those types of projects. Right, so we've got one terrain. Now, as soon as you've created it, you'll notice you get these little cells around here where you can add multiple terrains. If you don't, just make sure that the terrain is selected and then you click on this button here, which will reveal the grid. Now, we're working with multiple terrains, so let's add a few extra terrains. This will do nicely. Now, the thing that we need to consider is all of the height map values that need to go on these terrains. Essentially, we're creating a blanket. So imagine you've got this great big blanket and it's going to fit across all of these terrains. And then that blanket has all the height values in it, and you want to transfer the height values out of that blanket onto the appropriate terrain surface that are down here. Now, of course, this blanket is just a 2x2 matrix of float values representing height. The trick is in aligning what the values are in that 2x2 matrix to the actual surface of these terrains. Each terrain has its own height map, but that height map is in values from, or the indexes of that height map, which again is a 2x2 matrix. The values start at 0 and they go up to whatever the width of that height map is, which might be 512, for example. So this height map here has values from 0 to 512. This one here from 0 to 512. So each height map is locally based to the terrain. So it's quite unhelpful to use those values to try and pluck values out of like a global world matrix that's sitting across the top of here. So what we have to do is basically use world positions for both items as such in order to match them up. We have to put them into the same coordinate system. Basically, it's very similar to things that you have to do with 3D objects when you're trying to sort of move them around relative to each other, is, make sure they're in the same space. So what we're going to do in this tutorial, rather than learn algorithms like Voronoi and midpoint displacement and put them into a 2x2 matrix, is we're going to use a height map, because a height map is a 2x2 matrix. Now, by height map, I actually mean an image of a height map. And you can see I've got a few sitting down here in my assets. What you're going to need for your height map is just a texture that's black and white. Now, it can be anything. So white is basically high values and black is low values. You might find a height map on Google. I've created one here. So this is in Affinity Photo, so just a paint program. I've used a Perlin noise filter to create these blemishes over the background. And then because I kind of wanted to know where things were, I put some very distinct black parts in that image so that they will actually show up as very flat areas when I put them onto my terrain. Now, how big do you make those images? Well, if you wanted it sort of pixel for world pixel, then you're going to end up with a massive image covering the entire world space. Each of the terrains that I've got here are 1000 by 1000 in size, in world position size, and you can see that by looking at the coordinates of where they were actually placed in the world. If you're using smaller ones, then of course their world values be smaller, but essentially if you're looking at 3 terrains like this, you're looking at like a value of 3000, and if you want to use a image height map, it would have to be a 3000 by 3000 to cover that entire area. Now, the more terrain you've got, the more impractical that kind of is. It's quite a big matrix. You can, and I will show you how to use something that's a bit smaller just by stretching it out a little bit. So I've got a few height maps that I've created in my assets just here. This first one that I've got is 256 by 256. The second one I created is a lot bigger actually, so it's 2048 by 2048, and then this one with the crosses and that, it's really big. It's 4096 in size. Okay, so it doesn't matter what size height map you create, will cater for all of them. It'll just give you sort of, I guess, better resolution in the end if you use a really, really high one. All right, so back to our terrain. We're going to write some code to put onto another game object in the scene that's going to loop over all of the terrains and set their heights. So in here we will create an empty, let's call this our terrain controller. If you are following on with this from the previous lot of tutorials, which are at the beginning of this particular playlist, then you can add to your controller that you created before. So here's my empty controller, and I've created a new script. I called it multiple or multi-terrain height map. That's my script. I'm just attaching it onto there. Let's have a quick look of what's in there, which is pretty much nothing. So this is it, basically empty, but as I said before, you can add to the control you've already created. Now the start and the update we're not going to use, so let's just delete those out of there. All right, now in order to get this to update in the editor, we're just going to start with a little bit of hacky kind of code. So I'm just put hatch if Unity editor, because we only want this code to run in the Unity editor, and it will only run in the Unity editor when you're using settings on the side in the inspector to control the height. Now there's an issue with the onValidate in Unity, and what onValidate does, let me just type that in, is it actually runs whenever you make a change in the inspector to a value, which is quite nice if you want to keep running this particular code. Now, just above here, I'm going to add in something public that we can actually change the value of, and that will be, of course, our texture 2D, which will be our height map image. And remember, again, we're just using our height map image as a kind of placeholder for a matrix that is a 2x2 of float values, which is identical to these height values here. So if you're wanting to not use the image and use your own just matrix of heights, then that's easy to substitute in here. Okay, so we've got our height map image, and then later on we're going to use a scaling value. So I'm going to put that in now so you can actually use that to modify the inspector, even if you don't want to change the height map itself, so that you can just force that onValidate to run. Okay, so let's just put a scale range of, let's say, 3 in here, and that will go into a public float height map scale, and I'll set that initially to 3.0 F. Don't worry about that for now. As I said, we're just going to use it to make sure that this gets triggered. Now, the other thing with triggering onValidate is that you might get some error messages that come up, and I know that they do come up on Windows, even though I'm on a Mac, so I don't get to see them. But to fix that, we create this sort of extra onValidate. So it's not the onValidate, it's our own onValidate, but we make sure it gets called at the end of a onValidate, if that makes sense. So what I'm going to do above here is make sure that happens. So void onValidate, and this is not going to go with the automatic brackets that I just got there from my editor, but what I'm going to do is to set up a delegate. So Unity editor dot editor application dot delay call and plus equals onValidate. Okay, so what we're doing is we're delaying the call to onValidate till everything else in Unity has kind of finished updating itself in the background, and then we're going to run our own onValidate, which happens to be this one down here. Okay, so we've now got that. Make sure that you have a hash and if after that editor bit. Now all of our code is essentially going to sit inside of there. Alright, so what we're doing in here is, first of all, we're going to run a load same texture all terrains. So just to get a feel of how the height map is going to load on like a single terrain, we'll just do it across all of our terrains. So after this and if, I can actually put my public void load same texture all terrains. And then in here we can load our height data and put it onto the terrains. So to work with all of our terrains, we want a for each, and we'll say for each terrain in terrain dot active terrains with an S, because we're going to loop through all of the active terrains that are in the scene. Terrain data for a particular terrain, let's call that terrain data, equals terrain dot terrain data, just to make our code a little shorter. Then we want an integer of our height map resolution, which will be equal to our terrain data dot height map resolution, and that's the X and the Z sizes of the height map that belongs to the terrain, not the height map that is the image. But what we're doing is we're getting values out of the image and we're going to plug them into the terrain here. Okay, so we will create a float which will be our height map data, and that's going to equal a new float array, which is the resolution by the resolution. Okay, so this is our X and our Z direction values for that. Then we need a nested for loop to loop through all of the values from our image and to plug them basically into that height map. So for int X equals 0, X is less than HMR plus X, and some squiggly brackets. Then we want a for int Z equals 0, Z is less than HMR plus Z. Okay, and then inside of here we will get our value from our height map and plug it in. Okay, so let me just put a space in there. I don't know why that didn't do that automatically for me. So height map at XZ plus equals height map image dot get pixel. So we're getting one pixel at a time, which has a value in it between 0 and 1. Okay, so we grab it out of there. Now, the interesting thing that we want to do here is to go from floats to ints, so that we can put these values into our height map. Our height map has float values between 0 and 1, where 0 is like right at the bottom of the terrain and 1 is the maximum height of the terrain. Now, black and white values or grayscale values in colors are also between 0 and 1. So that's how we can actually use that particular data. All right, so now there's going to be a lot of brackets going on in this code, so just keep track of it. We have get pixel, and then in brackets by itself we have int, because whatever we are calculating needs to be an int. Then we have another set of brackets to do our calculation. Okay, so then we have X divided by HMR. Now, HMR and X are both integers, and we actually want some float values going on in here. So we don't want a pure integer thing, so we can divide X by a float in that particular case. And then we're going to multiply this by float height map image dot width. Okay, so that's our first value, and I'll come back to talk about this width in a moment. Let's put our Z value in, which is pretty much the same. So we're going to get all of that and put this down here and change these to our Z values, and then this time it will be our height of our height map image. Now, with that value, we need to return not just a get pixel, which returns, as you can see there on the screen, a color value. We want the grayscale from it. So it's grayscale like that at the end, which will give us a value between 0 and 1. Now, remember earlier when I said we need to get our our matrices or our matrices in the same space. So we're all working with the same kind of values. The height maps themselves, okay, that belong to the terrain are indexed between, say, 0 to 512 or whatever you've got them set to. When we loop around each time, we actually just want to find out what the percentage is of X out of our height map value. So therefore we divide by the height map value. This will give us values that go from 0 to 1 because X is going between 0 and HMR, which might be 512. Therefore, dividing by it is going to give you a normalized value between 0 and 1. And values that go from 0 to 1 in the Z. So essentially we've normalized that. And then what we're doing is getting a value from our height map image. Now our height map image also has an array that goes from 0 to whatever the size of the image is, which is like 512 or 1024 or whatever you've got it set to. So we're finding the percentage that we are along the terrain's height map, grabbing that value and multiplying it up by the width of the image, so we're getting the same point in the image or the same point at the same percentage along on the image. And this is basically a mapping formula that you use when you go from one kind of calculation area into another one. Okay, so that is setting each height from your image. Then what we need to do after we've gone through those two for loops is to do a terrain data dot set heights, and we're giving the heights the entire height map. So we actually start from our 0, 0 position and we just say height map like that. Okay, so we're ready to try this out. Save it. Let's go back into Unity. Now over in our script we will have a space revealed for our height map image and our scale. We want to get one of our height maps. It doesn't matter which one you use. I'm actually going to use the small one just here, and that is my 256 by 256. In order to use it in what we're doing, you need to make sure that it is set to read write. So select your image. Over in the inspector, we're looking for a type, obviously, of default texture shape 2D, but more importantly, in advanced, you'll find this read write value. Make sure you tick that and then just click on apply. If you forget to do that, Unity does give you a nice message in the console saying that that's what the issue is. Now, I've got an error going on down here, which I'm just going to assume at this point is related to the fact that this has run and on validate, but I actually don't have any height map in there. So let's grab the old height map here and we'll drag and drop that into our height map image area, and boom, there is our height map spread across each separate terrain. Okay, so notice how we're not doing anything continuous whatsoever. We're just putting a height map on there. Now this particular height map, you can see it's very low resolution. Because it's low resolution, you're getting this really interesting kind of terracing going on the surface of your height map, and that's basically because you're trying to stretch out pixel values. So for this single point here, which is like somewhere in that particular image, it's not just that point, but you're stretching it out for so many pixels so that you can get a tiny sort of height map and spread it across basically. But what you can see is that everyone is exactly the same, which is not what we're going for, but at least it is a start. Okay, so I'm going to end this video here. When I come back in the next one, we will start looking at how we actually spread one image across all of the terrains so that it will be continuous.